So what I'm going to talk about is how data analytics architectures are changing over time. So in the past, BI was king, and everyone did their analytics with BI. They did it with SQL. That was the way people did it. And things changed. And now people are doing it a different way with data lakes, and they're doing all these different kinds of analytics. And now they're starting to merge into one thing. And I'm going to show you some example architectures and talk about that sort of changing arc as things go on. So I showed you this, guys, while you were sitting down. So this is just a sample of some of the people that are using our software. And obviously I'm going to talk about my software, but to say that Vertica is the only analytics database that does what we do would be slightly disingenuous. But we do all of these things for these cool people. And the thing about it is we both do BI and data science. We're both a data warehouse and a data lake, and we're merging those together and becoming one thing. And let me show you how that works. So I'm going to set the Wayback Machine a little bit. So everybody knows what a data warehouse architecture looks like? Does everybody know that? Okay. Yeah, I've been in the business for almost 25 years, and this architecture predates me by quite a bit. It's been around a while. And the reason that it has been around a while is that it's very strong in certain ways. I mean, because this industry, everything changes really, really fast. The only reason that this has still been around is that it has some amazing strengths. So what are the strengths of a data warehouse architecture? Well, the number one thing is it de-silos all your data. So if I have 5 different analytics databases or 5 different transactional databases, plus I've got some data coming in from 2 or 3 other places in file format or whatever, I put it all together in a single place, and then I can do my BA reporting on top of that. And that's powerful. And that's pretty cool, you know, and you would think that everybody would have that because of the cool aspects of it, the high performance, high concurrency. It's really good at 100 users hit your analytic database at the same time. Doesn't matter. It can handle it. And it's also very mature software. It's reliable, it's got great governance, security, all that stuff like that. And it's all done with SQL. And who here does not know how to do SQL? Is there anyone? Oh, look, there is a person, two people in this room who don't know how to use SQL. The truth is that almost everybody who works with data on a regular basis, they usually know at least the basics of how SQL works. And that means that you have a huge army of business intelligence, business analysts who know how to use SQL. And that's great. So this is wonderful. So I'm going to use Uber as my example because they've done this journey. And they started out back in 2014. This is a slide that they presented at Strata 2016. And they were talking about, this is the way we used to do it. We had a big old Vertica database. We gathered everything together. We tried to put our Kafka logs up on S3, but we took the important stuff and put it in the database. And we did our ETL, and we tried to do our data science, some of our city ops and things like that, all on the data warehouse. And it was really kind of like more than most data warehouses can handle. Because back in the day, data warehouses some pretty serious weaknesses. One of the weaknesses was, back in the day, data warehouses were expensive to scale. Particularly if you had like an analytics appliance, like if you had Netezza and I needed to scale it up, I was got to go and buy a bigger box. It's like there wasn't that capability of buying inexpensive, off-the-shelf hardware computer nodes and just scaling out as big as I want to. That wasn't a thing with databases. It only handled structured data. So if I had streaming data or unstructured data or any other kind of data, my data warehouse wouldn't do it. The ETL, the consolidation and stuff was usually batch-based. A lot of times it was scheduled at 3 a.m. or something when nobody was doing their queries. So it tended to be day-old data. It tended to be a little stale. So I could do all kinds of really fast analytics and know exactly what happened yesterday, really quick. And that was a problem. It was only business intelligence, and it couldn't handle that streaming data in particular. That was for IoT use cases and things like that. So did people fix the data warehouse architecture and make it better to fix it? No. They threw it out the window and started over with a different kind of architecture. They decided, hey, data lakes, that's the way to do it. I can throw all my data in there. It's very strong. And again, this is not as old as the data warehouse architecture, but it's been around more than 10 years. It's a very strong architecture. It's got some really amazing advantages. I can put anything in there. It scales affordably, so I can get as big as I want by just adding inexpensive computers, or even better, on the cloud, I can just make my S3 bucket or my Google Cloud Storage larger, and I've got plenty of room. I don't have to worry about how hard it is to scale. Or how expensive it is to scale. Usually that's affordable. Then I try and put my data into a format to do machine learning. It's almost always data science is focused on data science, machine learning, and things like that. But here's where the problem came in. Most people want to use Python. They want to use R. They want to use a Jupyter notebook to do interactive, that kind of thing. Those tools are really designed to only work on data that can fit in memory on a single machine. Which means if I have a data lake that's taken 50 machines, what I have to do is pull a sample and try to make sure it's a representative sample and try to make sure I get, I don't miss anything. Maybe I have to do multiple samples and try and do each one individually. I'm going to have a lot of problems, but essentially I have to take what I need out of the data lake and go somewhere else and actually do data science. That's where I actually do the work. That's where I'm going to iterate through my models. I'm going to do all my data preparation steps somewhere else. Then when I'm done, I have a really nice model that isn't good for production. I can't put it right into production. Somebody else has to rebuild it. A lot of times it's a data engineer, and they're going to have to rebuild it in Spark or something like that. Something that scales, that is not really fast for iterations like Python is, but that can handle highly parallel, huge amounts of data, and can put that model to work. So back in 2016, Uber said, we're going to throw out our data warehouse, and we're going to do a data lake, and that's what we're going to do. We're going to go all in, and then they said, and this is why. Look, it's got all this cool stuff. And then that's not what happened. This is what happened. So this is from Strata 2018, when they were talking about this is what our data architecture actually looked like. And what is they've got that Vertica data warehouse, and they've got a data lake, and they're making all of it work together, and they've got their machine learning data science in one place, and they got their BI guys doing experimentation and deployment and trying to a lot of pipelines and stuff like that. But they have the strengths of both architectures. And that was the cool thing about it. So this is why they ran into the weaknesses of a data lake alone, and they figured that out. It's slow performance. And this is probably a shock to a lot of people, but, well, it's not a shock to a lot of people that MapReduce sucks. MapReduce is super, super slow. So no matter how many nodes you have, whatever job you're trying to do, it ends up being a slow batch job if you're using MapReduce. Well, Spark came along and pretty much replaced MapReduce. Nobody does new development with MapReduce anymore. They all use Spark. Spark for data transformation and for data pipelines and things like that. It's awesome, but it still is not nearly as performant as a database. So there's that. And even now, even today, they have problems with concurrency. So if you put more than 10 things trying to happen on a single Spark cluster, it's going to fall down. Chances are the performance that was already not so great is just going to drop through, and some of them it's going to fail. And that's a big problem. So concurrency was a big deal. And it's really complicated. I got to say, putting both of the, that's a really complicated thing to do. And it's really hard to operationalize your ML because they had to go do it somewhere else, and now they're trying to operationalize it. A lot of surveys show it takes between 30 days and a year or more just to operationalize a model after it's already been created and implemented. It's already been trained, it's already been evaluated, it's good to go. That's crazy. If I've already got a model that's really good, I want to put it into production immediately, if at all possible, because data drifts, and I'm going to have to retrain it if it doesn't. If I can't get it into production for 6 months, by then it may not even be a very good model. So that's a problem. Okay, so what's the solution that Uber came up with? Is they smooshed them together. They put the sort of the data warehouse, and they got all those strengths, and the data lake, and they got all those strengths, and they made this cooperative architecture that's big and complicated, but it has all the strengths of both architectures. So they had the ability to do their stream processing, and the main thing they did was they streamed their historical data into the data lake, and they do, along with all their transactional data and their files and everything else, and they put it all in there, and they did their, they put it in Hadoop or in object storage on the cloud, depending on how you implemented it. In Uber's case, it was mostly on AWS. And then they do the ADL, they data prep, they put it in something like Parquet. Parquet is a nice columnar format, ready for analytics. And they do some of it, they put the hot data up here in your distributed analytical database, in Vertica or whatever your database is that you do analytics. And then when they've got the models operationalized in there so that when the high-speed current data comes in, that can immediately respond, and it can drive business intelligence. It can be used for data science, but that's usually done here. And it can drive your applications. That's a big thing. If I've got AI or I'm automatically doing something because a real-time streaming process came in, then I'm going to do it this way. Problems. Well, you still got your BI team mostly working in the database, and you've got your data science team still having to take samples out and go do their job somewhere else because this is still too big. You still can't fit it into memory on a single machine. And so to operationalize it, I still got to put it into something else. I've still got 3 to 6 months or a year or more to operationalize my machine learning. Plus, if these guys need data from up there, they're going to have to go get it. There's like pipelines going everywhere. It's crazy. So it's a good, it is a good architecture. It has all these crazy strengths, but it is also a difficult architecture. So this is a good example of where Uber was a year or so ago, before COVID. So I don't have their up-to-date thing, but this is where they were a little while back. They've thrown everything into a database, into a data lake, doing their ETL with Spark on the data lake, put it in Parquet, put the hot data into a database, and they're doing a lot of data science using Hive and Presto and some Spark and some Jupyter notebooks. And they did something cool. They also have multiple databases copies because they have a really high volume. They test for 100 petabytes. I don't actually know what their actual is. I estimate around 60, but they test their everything for 100 petabytes. So this is an architecture that can handle 100 petabytes. And they duplicate this so that they can do a lot of things simultaneously. If every person in this room called up Uber and asked for a ride, every single one of them would go into a Vertica database and optimize the geospatial analytics for that to give you a ride in under 7 minutes. Because the geospatial analytics is built into Vertica, and it's faster than geospatial analytics in a data lake, and that's why they're doing it there. So they wanted to do it with Python, because that app that you're punching buttons on is a Python app. So they built Vertica Python, and they open sourced it. It's a client for Python. So now I can write Python commands, and they can go in this database, and it doesn't matter if this is 60 petabytes, I can get the response in under a second, and I can do it even though I have 60 petabytes of data. So that kind of gives you an idea. So here's another example. Now these guys also have a combination architecture. In this case, I think you're starting to see the merging of the database and the data lake here. because a lot of what the data lake is used for is ETL. That is what you see again and again, is instead of doing ETL, where I extract the data, I transform it into something really awesome for the thing that I'm going to do analytics on, and then I load it into the database or wherever. Instead, I'm just pulling it out, loading it into thing, and then doing the transformation inside. So I'm getting ELT instead of ETL. And that's what I'm seeing in here, and they're using Spark to do that. They're also doing some stream processing, and they're putting that data straight into Vertica. And they're using Spark to do some of the machine learning, as well as the BI over here on SQL. They use Domino to sort of manage it all, because they're trying to do some machine learning inside the data lake and some in the data warehouse, and they're, they got to keep track of it all and make sure it all is organized correctly, both the teams and the models themselves. So, what is the strengths of the cooperative architecture are? Everything. Basically, you have all the strengths of the data warehouse, all the strengths of a data lake. What are the weaknesses? Too complex. Oh my God, if your data lake was complex, this combination cooperative architecture is insanely complex. Trying to maintain it is crazy. There's a lot of duplicated effort because I'm trying to get data for the BI folks, for the business analysts, and I'm trying to get data for my data scientists also. And a lot of times it's the same data, but I gotta channel it to multiple locations, and I gotta move it over here and then transform it, then move it over here or over there. It's crazy. So that's one of the big problems with it. And the fact that the teams are still divided. They're very divided. It's like the BI team and the data science team are in their own worlds. They never talk to each other, even though they're both trying to do analytics a lot of times on the same data. All right. So that's the cooperative architecture. So what is the solution? Actually, hang on a minute. Is we start out with a cooperative architecture. What are we going to change to make it better? Well, first time we unify the storage location. The cloud did us a favor on this because object storage is great for storing anything, including database data, structured data. So Vertica, for instance, has what we call read optimized storage, ROS format. That's what all of our data is in, and it is a file object storage kind of. So we store it in the same place your Parquet data is, and the same place your Orc data is, and the same place all your other data is, and we can analyze all of it. So that's awesome. And you can also do that on-prem, because the on-prem guys are like, well, lots of people want to do private clouds. They want all the advantages of cloud, but they want to stay on-prem because maybe they have regulations. You've got, highly regulated industries that say, I've got to keep this on-prem. I can't put it in the public cloud. But I want the advantages of a cloud. Well, so there's lots of folks now doing object storage on-prem that gives you that ability to do cloud stuff, presentation. So it's all in object storage. Now what do I do? Well, I can manage the data lifecycle. I dump everything in when. I do the transformation. I put my hot data in my highly optimized super format. I put my colder data in Parquet or something like that that I can store forever, and that's great. What else do I do? Well, I unify the analytics. I make sure that I can use SQL, I can use Python, I can use R, I can pick up my Jupyter notebook and do an interactive data science workflow and never leave the database. The database does all the work. So if I have 10 petabytes of data, I don't have to try and extract enough to fit in my in-memory system in order to do data science on that. I leave it in the database. Database does the work. I write Python. The database engine, which is highly optimized, does all the work. So that's awesome. I get to use whatever I'm used to, but the power of the database behind it. I make sure that I can query every data format. It's like it doesn't matter what format your data is in. You should not have to change query capabilities just to analyze a different kind of data. If I want to query Parquet data long term, if I want to query my own ROS format that is really fast, I want to query JSON data, maybe I want to do schema on read, not a problem. I should be able to do one query engine. So that's a single engine doing all the work. That's great, but one of the things that we noticed as Vertica was we had customers going, we'd really like to have machine learning in the database. Please put it in there. We put it in there, they didn't adopt it. We're like, what the heck? You asked for this. How come you're not adopting it? And the answer was because they had a Business Essential BI running on this database. The last thing they wanted to do was to cause it to bog down performance or even to fail because they were trying to train a machine learning algorithm at the same time. It's like we can't have those two bumping into each other. So we learned how to isolate workloads. So that if, for instance, I have streaming data coming in, I can't wait until 3 a.m. to do ETL. I have to process that data, ingest it, and combine it with other data sets and do all of that constantly. That data is coming in all the time. I need to be able to deal with it all the time. So that's isolated. Machine learning, if I'm going to hog all the resources to train a machine learning algorithm, fine. If I need to do reporting and my boss is trying to, click on his report to see how his company did last quarter, my reporting needs to be just as fast, and none of the other things should impact that. And we did that with sub-clustering. So back in the day, back when I was working with Hadoop, people would have multiple clusters. You'd have hardware. You'd have like 10 machines here, and they did machine learning. And you had, 10 machines over here that did something else. It's like now, with the cloud concept of separating of compute and storage and being able to spin up compute as you need it, you can spin up 10 nodes and say, this is dedicated, has lots of memory, has lots of power. These 10 nodes are doing nothing but machine learning. Data scientists, that's yours. Business intelligence guys, here's 4 nodes. You probably don't need as much power, but you need to drive those, your reporting, and you need that not to be interfered with. Fine, those 4 nodes are yours. And you can run them all at the same time, and they can share data because all the data is shared. So that's pretty powerful. The last thing that went into it was the ability to train a model and move it around. So if I train a model, let's say I train a TensorFlow deep learning model on a GPU machine. I don't want to spend the money to put all my production data on a GPU machine. That's crazy. So what do? Well, I train my model on the GPU machine, I put it into the database, boom, it's in production. It's that simple. If I train a model inside the database, I save it as PML, I can go put it somewhere else. Vice versa. I can put a model I trained somewhere else, and one that I trained there, I can put them together, I can evaluate them both, and decide this one is better, and put it into production. Save them both as, they save like tables. So you have the authorization, all the things that you get from a table. So that's pretty powerful, and that's what Vertica does. I mean, people all day at the booth, they come up, they go, what the heck is Vertica? And I'm like, go see my presentation, let me talk for a while. The thing of it is it combines the power of the data lake and the power of a data warehouse to give you all of the things, including Unified Analytics. So I can use SQL, I can use BI tools, Python, Jupyter, R, anything you want. And here's some examples of some folks who are doing this. In this case, this is Philips. These are actual, this is taken from a Philips slide. And they're doing predictive maintenance. So they dump all of their data into a data lake. They do some refinement on it. And then they throw it in Vertica, and they train the machine learning models using Python or R. They even can create their own algorithms. Let's say I want to create something that's my special sauce that's better than anybody else's algorithm. I can do that, and then I can put it in Vertica, and it will distribute it across the entire data set. If I got 50 nodes, it'll parallelize it 50 without me having to do anything. And that's pretty awesome. And then after they train it, they figure out, okay, now I know the pattern for a component in an MRI machine at the hospital in Cambridge, and I know that pattern, and as that data comes in now, I can use my machine learning model to say, oh, wait, that's about to break. Let me schedule a maintenance, get that fixed. It's not even broken. Well, yeah, but it's gonna break. Let me fix it so it never breaks. So that machine is never down. Zero downtime is their goal. Simplifi is another one. They do ad targeting. Now this is the power of a database. They're throwing everything. They're doing a little Spark ETL to refine it. They're throwing everything into their database. And then they're actually doing all of their machine learning and response and everything in SQL. And what they're doing is ad targeting. And they have a 200 millisecond response time requirement. If I click on an ad and I browsed a fishing boat last week, it's like when that thing, when that web page comes up and I've got an ad space, you're going to get bidding from, the guy that sells the fishing reel and the guy that sells the lures, and you're going to get bidding from, I don't know, somebody that sells underwear or something. It's going to be something completely unrelated to you. What's going to happen? That's going to come up and it's going to show the fishing boat that you browsed last week. Why? Because that's the most relevant ad to you. And that's what they do. And they have to do it in less than a second, or never mind, you've gone on to the next page and you'll never see that ad. Now the other thing they have to do, and in addition to that, automated ML, they have to do big business intelligence. And they want to do that on a more consolidated, aggregated data set. So they actually have a different database, and that drives their reports. And then their executives want an even higher level, more aggregated view, and so they have a whole nother database to do that. They don't have to do that, but that's the way they designed it. Now, United Group is really unifying things. They're using us both as the data lake and the data warehouse. They don't have their workloads isolated, but they are pulling everything into Vertica, and they're doing real-time ad targeting on television. So if I'm Gillette and I send you an ad that shows a lovely lady walking down, the pier wearing short shorts and slick, shiny legs, and another ad that shows a manly man standing in the mirror, and a girl comes and kisses him because his face is so smooth. It's like, I have these two ads. I have two people living side by side. How do I know which ad to send? And the answer is because they sell the set-top boxes, as well as they know what you watch. They know you're a 35-year-old woman with 2 kids, and you're a 40-year-old guy who's single. And they know exactly which ad to serve to each person. That's what they do with Vertica. I'm sorry, it's partially our fault. But it's better than, getting an ad for underwear or something that you didn't really want. Another one that uses us as their data lake is the Trade Desk. And they have about 15 petabytes of data on Amazon. And they have a pretty unique way of doing things because they also have the ad targeting capability. But while the majority of their ad targeting, 200 milliseconds is fine, in fact, they have to, some of their ad targeting, because they get a lot of different bids and things like that, they're the largest, other than Google, they're the largest ad targeting out there. They actually have to get some of their stuff back in 20 milliseconds, which Vertica will give you up to 100 milliseconds, but we won't give it to you in microseconds. So they put everything into Vertica, and then for the really, really, really fast stuff, they put it in memory in Aerospike, who's also here, so you should go check them out. And they do it in SQL and Python, and they do it in SQL and Python in both. And that's pretty awesome. They can do it wherever they want to, however fast they need to. And they have one subcluster that's up all the time. It's 128 nodes, and that does their ETL with their streaming data. And they do, as a value add for their customers, 40 to 50,000 reports every day. So every single person who bids on an ad gets a report on how those ads did. And they spin up 64 node clusters in Vertica to do those ads, and then when they're to do those reports, and then when they're done, they shut them down so they're not paying Amazon for all that compute. And if they want to do ad hoc querying or some machine learning or something like that on that, they can just spin up a 64-node cluster and go for it. So that kind of gives you an idea. So if you want to learn more, there's a lot of folks, TWY, MA, a lot of folks talking about the Unified Analytics Warehouse or the Unified Analytics Platform, which is what we call it because it's not really a warehouse anymore. And if you want to learn more, upskill, go to academy.vertica.com. It's free training, including certification on demand. And that's all I got. So if you guys, I will answer questions, but also if you guys still want to talk to me, go back to the Vertica booth and I will be signing 97 Things Every Data Engineer Should Know by O'Reilly, and I'm one of the contributors to it. So go for it. What you got? How much time have I got? Am I out of time? 1 minute over. All right, well, come to the Vertica booth and ask me there.